Okay, we just step into the chapter about 3.2 and we just neglect the typical distribution functions like the the normal distribution, exponential distribution, Poisson distribution, and some uniform distribution, so on. So directly to step into some key points that independence of random variable. This is just what is the independence. Independence means that they don't interact with each other in this system, and so we can directly to do some practical computation about them. And so this is just the some of something that we can do because of the independence. We can this is the probability function that we can directly to do something that analogous definition that if they can be represented by the multiplex, um, we think they are independent if and only if they can represent as this form. And also, what is the independence? Two independent are said to be independent if for every pair of x that both the proper probability function and the probability density function can represent this form. Suppose that find the joint probability function. Joint means that they can be represented in a huge map. Find the values of a and we call the table. Suppose that the joint table interval such that x vertical, x and y are orthogonal. Okay, so we should do some very easy, I think. We can represent the okay, here we go. This is just the 3.7 short method. 2.9. Oh, Chinese is fluent. So that these are just the normal independence or normal variable, normal distribution. If and only if though it is larger than independence, it's going to be that the related uniform. Suppose that xy has a uniform distribution over D. Suppose that are they dependent? The uniform distribution. Delta y equal 0 1 pi 0 is equal three times. We know that fxy xy equal to what? All this is just this chapter we have neglect. We directly step into this chapter. So little funny. And what is wax is the one is just uh, triangle angle. How to the square the angle triangle The marginal is what? Okay, let's pay attention to that. It's not about the minus 1. It's just about b represented as x. Independence of random variables. In fact, we have a necessary and sufficient for random to be indivisible in a rectangle. Okay, rectangle. I forget this. It's in word. Given values that we in as be a rectangle. S is a rectangle. S is one for z of xy for every point outside. Then the continuous or discrete random variable. If and only if they can be represented as hx, gx, then the continuous random variables are independent if and they can be represented as, so they can be split into different groups, and there are only x groups and y groups. Okay, so this is the independence of random variables fx, x, y. Suppose that x1 is equal to 0 outside the oscillator because they can lead directly into the different groups. That means variable split divided. And no, I mean the joint density function factors, and thus the random variables are independent, with one being iterative and the other exponential with raise 3. Because they are not the rectangle, let x and y be even. Then for any g and gx are intended. For any real function es and es, for any real function, all of the random values are if and relative. Okay. When they are discrete, when they are continuous, oh, they are the different type. But repeat again, that is to say, if they are independent for any form, any real function g dot h dot gx hx independent, the others are independent and conditional thing. Goodbye.